Alright, in this video we're going to learn about Coulomb's law with vector addition. In our last video we finished off looking at Coulomb's law, which was a way to quantify the force that one charge exerts on another. So if I look at this, if I know the distance here, x, and I know this distance here, if I have a charge for Q2 and a charge for Q1, I can find the force that it exerts on this guy. And once again, if I know this distance, I know Q1, I know Q3, I can find the force that it would exert on him as well. So if I have these two forces, I can add them up through vector addition, through finding the components in the x and the y plane, putting it all together, and then finding the net force that two individual point charges exert on another. Alright, it sounds like a lot, but we've learned how to do this before, and it's just a step-by-step process. We just have to keep everything organized in terms of our labels. Alright, so what's the force that Q1 and Q2 exert on Q3? So Q3 is 30 microcoulombs, Q1 is 10, Q2 is 20. Now, in terms of positive and negative, when we're finding the forces, we're not going to worry about who's positive and who's negative. It's when we start to add our vectors is when we're going to go back and say if we're adding them or subtracting them based upon if it's an attractive or a repulsive force. So first we're going to find the force that 1 exerts on 3 and that 2 exerts on 3. So F1 on 3 is equal to 10 e to the negative 6 times 30 e to the negative 6 times k constant, 9 e to the 9, 5 gets squared into my calculator, 0.108. And that force is kind of up like that. Little arrows just help me remember these things. And then the force that 2 exerts on 3 is also going to be 20 e to the negative 6, 30 e to the negative 6, k constant, 9 e to the 9 times 4 meters squared into my calculator, 0.3375, and that is all in the negative x plane. Alright, so I have my two forces. I know how to do that. That was Coulomb's law. So now what I need to do is I need to take this force here and I need to break it up into its x components and y components. So if I know this angle is 37 degrees, I can say the force that 1 exerts on 3 in the x plane is equal to the value that I got, 0.108, times the cosine of 37.5. And I get 0.086 newtons. Likewise, in the y, force 1 of 3 in the y, 0.108 times the sine of 37.5, and I get 0.065 newtons. So here, this value is 0.065, and this value is 0.086, and this value we found to be 0.3375. That's a 3 out there in the front. So I have all three of my vectors. Since this guy and this guy are going in opposite directions, I'm going to subtract them. So when I look back over here, we said this force was 0.086. Here was 0.3375. So when I find the difference just in the x plane, I get a net force of just 0.25 newtons in the x. And the overall force is going that way to the left. Since there's only one force in the y, he winds up just being 0.065. So I have a force this way and a force this way. So I'm going to find my net force by Pythagoreaning them together. So 0.25, 0.065, 0.25 squared plus 0.065 squared, all under the radical to find this guy right here. And I should get 0.258 newtons going in this general direction. And that is Coulomb's law with vector addition.